Okay, so welcome to the next latest and greatest webinar on the textbook review of C++ programming here by Malik. We are in the middle of, I believe, chapter 2. And I think with the last webinar, we got to page 70 here. And again, I want to reemphasize here that these webinars are by no means a replacement for the textbook. Okay, what I'm trying to do is bridge the gap with the information that's in the textbook and the high level understanding, so that a lot of you are new to programming, and I want to try to bridge those gaps so that when you look at this textbook, right, all the really good software engineers I know have an entire bookshelf full of textbooks, and they know exactly which textbook to pull. They know exactly which textbook to go to. And that's my intention here, is that we're all very familiar with the textbook. We're all very familiar with the content, and we know where to go, as well as feedback to the publisher, right? Because I've seen the same mistake made over and over again with multiple publishers when they present this information. So I do want to provide some feedback to the publisher. But last webinar, we got to page 70. So I want to progress past there. So we're going to go on to page 72 here, and we're going to start to talk about output in chapter 2 here. And you're going to see that with C++, the way we create output is with what's called the cout statement. Okay, and the cout statement basically stands for console output. And the way the cout statement works is we utilize this direction operator, this less than sign here, and anything presented after that less than sign is basically sent to the console's output, as long as it is proper data that it recognizes. And notice that we can use more than one of these redirection or less than operators to send more than one piece of data to the output. But yeah, we've got a cout statement, we've got this redirection operator, we have our data, and then at the very end we have a semicolon, right? As with most C++ statements. Okay. All right, so they're giving us some examples here. Obviously, ch, well, not obviously, ch is a character variable, and so we are able to output whatever the values are that are contained within these variables directly to the output. So that is always a possibility. We can take whatever those values are and redirect them to the output. We can also take what's called these literals or these hard-coded values. For instance, we have a string here or a single character called A in between quotation marks, which means that this is a string or a character, and we just want to output that directly to output. So either one of these will work if we want to output the character A, assuming that this variable called ch is the value A. But again, at a high level, what this is trying to point out to you is how these cout statements work. Okay, so then they give us some pretty good examples here. In example 221, where, for instance, we can even include some mathematical formulas directly inside of the cout statement, and it will calculate whatever the value of 29 divided by 4 is, push that to the console output, and then it's called endl. So endl stands for end line, and I think we talked about this earlier. There is what's called a new line character, an escape character, \n, that enables you to force the cursor to the next line. And they don't do a very good job of showing that here, because you really need to see the output of more than just one line of code. But basically what they're getting at here, 29 divided by 4, 29 is an integer, 4 is an integer. So when it takes 29 divided by 4, it's not exactly equal to 7, right? It's equal to 7 point blah, right? There is a remainder, right? Because 7 times 4 is only 28. There is a remainder and there is a decimal, but with computers, it's always converting apples to apples, right? So if it sees an integer here divided by an integer, it's going to store that answer into an integer. So even though there is a remainder, even though there is technically a decimal associated with this, you're only going to see 7 because the output also has to be an integer. Okay, so that's another very common mistake with a lot of beginning programmers, is that they just assume a number is a number, like in math class, and we can write out each input value however we want. But with computers, if you don't put a 0.0 behind this 29, if you don't put a 0.0 behind this 4, it's just gonna store the output as an integer because it sees an integer divided by an integer. So one of the keys, I do like this example because it points out that you need to make sure that the variables you're using are of the proper data type. And if you are interested in the remainder or the decimal portion, you need to put 29.0 here and 4.0 here. Okay. So integer divided by integer is integer. That's why we have 7 there. For line 2 here, cout, right? And we have our redirection statement, hello there, and then we have an endl. So technically, yeah, the output is going to be hello there, but it's going to force that cursor down to the next line such that any future cout statements is going to be on a new line, and it's kind of hard to see that with this table they've presented here. Okay. Well, cout 12, obviously it's going to print out 12. Okay, here, notice the difference between line 4 and 5 here, right? If we cout 4 plus 7 and it is encapsulated with quotation marks, you're going to see just 4 plus 7 because this is a string. Anytime anything is stored or presented with quotation marks, it is a pure string. There's no numerical value to it. There's no mathematical value to it. You're just saying, hey, I want to present this information to the user because it is a string. However, here on line 5, notice that notice that there's no quotation marks here, right? So it is going to take 4 plus 7 and add them together before it outputs it, right, to the screen, which is why we see 11. And again, we'll see endl at the end here, and it forces the cursor to the next line, but I'm not sure why. Note to publisher, why add these endl statements here? Because that's not what you're trying to convey, and you're not conveying that with this output information. So focus in on the first part of these cout statements here, and just make sure that you're comfortable with why the output is what it is, minus the endl statements. Okay, because you really need to have a program that outputs multiple lines to all right, so let's go on to this cout A. Notice that A is in between quotation marks, right? So therefore, we're just going to see the letter A. Cout 4 plus 7 equals, a lot of students who are new to programming see this, and they see this, and they go, well, it's the same thing. No, it's not, because this has quotation marks around it. So it's going to output that information directly. And in here, 4 plus 7 does not have quotation marks. It's going to do the math, right? 7 plus 4 is 11, and it's going to output the resulting value. Okay, so anytime we want numeric values or we want to perform some math, we do not want these quotations. The quotation marks are only good for presenting information to the user. They're not good for mathematical operations or numerical values. Okay, so that's why we have to do it in two separate places here. All right, line 8, cout 2 plus 3 times 5. Oh, well, here's an interesting one, right? Why does it output 17? Well, there's something called PEMDAS that we learned about in math, right? Please excuse my dear Aunt Sally. And that basically means that when you have a math formula like this, the computer is going to execute one of these operations before it executes the other. And that's because of PEMDAS. Multiply in PEMDAS comes before add in PEMDAS. So it's going to take 3 times 5, which is 15, and add that to 2, which is 17. And that's why we have the value 17 here. If we wanted to be really careful, I would suggest putting parentheses around this 3 times 5, because anytime we add parentheses, that forces the computer to do that operation first. And in industry, I always suggest adding parentheses regardless of the PEMDAS operations, because parentheses enforces that a particular operation will happen before the next operation. But just in case you're presented with a problem, maybe on a test where they don't have parentheses and there's multiple operations, they do expect that you understand order of operations, PEMDAS, and you will calculate this value properly. Okay, line 9 here, cout hello there. Notice how there is a \n here. And I think we kind of talked about this in previous sections, but the \n means new line, right? And so at least here, they're finally showing us what this endl or new line escape character does. Notice that hello appears on the first line, and then there appears on the second line, right? So this new line is forcing the character from this first line onto the second line. endl does the same thing. So you can use an escape character inside of the string to force the character on, force the cursor on the next line, or you can use endl to do the same thing. And typically the reason you do that is just to make the output more readable. Okay, so good examples. I do like the input and the output here minus the endl statements. It's not obvious what these endl statements are really doing. Okay, so the book does make note of this backslash character being called the escape character, and there's a bunch of them. \n is probably the most frequent one, and that means new line, which as I was talking about a second ago, forces the cursor to the next line before it outputs whatever the next data is. Okay. However, there's also this endl. It's weird how they present these examples. Note to publisher. You're explaining it down here, but you're giving an example up here. It should be the reverse. All right. But these endl characters do the same thing. They force the character. It stands for end line. Forces the character to the next line. So it's up to you. It's up to you if you want to use the \n or the endl in order to force the cursor to the next line of code. All right, so we get to another good example here. And again, it's important to be able to read code and interpret its behavior, right? Before we can actually write code, we should be able to read code. So what I'd like us to do is kind of look at this example here and make sure that we understand if this is the program, why this is the output. All right, so notice that every C++ program, very similar. All of your what's called preprocessor directives, and we'll learn about this later in the chapter. And again, I'm not sure why they talk about this later in the chapter. They should probably talk about it up front. We have these preprocessor directives at the top. We are going to learn about namespaces later on. Again, another topic that hasn't been presented yet. But this includes everything that we need in order to use these cout statements here. Okay, remember that every program starts with main. Okay, so that's why we see this main declaration at the top. We're saying, hey, this is the main method. This is where the program starts. And we declare a method, variables called A and B, and we make them integer data types on this line. So we've allocated memory for these two variables. Then we say, well, A is equal to 65, right? So before A didn't have a value, now it does, it's 65. B is equal to 78, right? We have this B variable in memory, now it's set to 68. And on line 8, we say 29 divided by 4, which I think we did up here, right? Yeah, 29 divided by 4. And because it's integer divided by integer, the output is going to be an integer, or 7. Okay, if we change this to 29.0 and 4.0, we would see that this is 7 point blah. It would be a much more accurate value of what 29 divided by 4 is really equal to. So it's very important that, especially when doing division, that we use the proper data types when doing so. And in this case, it's integer divided by integer, so we get whatever the whole number is, which is 7. Now look at the next line, 3.0 divided by 2. Well, here we have a float divided by an integer. So the good thing is that when the computer or the compiler sees this, it says, well, hey, one of these data types is a high precision data type, or a float. The other one is an integer. So I'm going to pretend both of these are floats. And I'm going to do 3.0 divided by 2.0. And notice that the output for that is an actual decimal value. So not for every language is a little bit different, but for C++, if it sees two different data types, it will automatically cast this integer to a float, because it's the precision of an integer is much less than a float. So it says, well, if you've got a float up here, we're going to go ahead and make this bottom one a float automatically. And 3.0 divided by 2.0 is equal to 1.5, which is why we see that for the output for line 9. Okay, and you will see test questions like that, right? Where they'll give you a formula and one just uses all whole numbers, but one of the answer choices is going to be a decimal. And that is not the way things work. If we have integers, you'll get an integer. If you have at least one decimal, you're going to get a decimal. Okay, so definitely remember that. Hello there with a \n or new line character. You see hello there, and it forces the character, the cursor to the next line. Cout 7, endl, which is a new line as well, or forces the character to the next line. We see the number 7. 3 plus 5, notice it's not in between quotation marks, so it will add those two together. And for line 12, we get the number 8, because it does the math for us. For line, 13, notice 3 plus 5 is in between quotation marks, okay? So lines 13 and 14, right? If we run this program, it's going to run this line and then this line. We're going to see 3 plus 5 star star, because notice there is no endl or \n anywhere here. So it's going to print this on the same line as this, which is why we see 3.3 plus 5 star star. Okay, so at least here they're trying to demonstrate what it means when you don't have an endl or you don't have a new line character. Okay, next line, see out 2 plus 3 times 6. Well, they're all the same data type, so we don't need to worry about casting to maybe a float or a decimal. However, we do see multiple operations going on here. And the question is, well, is this evaluated first, 2.3, excuse me, 2 plus 3, or is 3 times 6 evaluated first? And if we refer back to PEMDAS, please excuse my dear Aunt Sally, or parentheses, exponent, multiply, divide, add, subtract, we're going to see multiply happens first and then add. So we have 18 plus 2, which is equal to 20, which is what we see for line 16. For line 17, we see quotation marks around the A. All right. And that is basically saying, well, just print whatever's inside of these quotation marks here, which is the letter A. So anytime we see any information in between quotation marks, that is just letting the computer know that, hey, that is a string, and just print whatever's in between it or store whatever's in between it. All right, so then on line 18 here, see out A, notice there's no quotation marks, which means that A is a variable. And then the question is, well, where is A defined up above it? Because if it's a variable, it has to be defined somewhere above it. Otherwise, the computer is going to freak out. And if we look all the way up here, aha, this is where A is defined, is equal to 65. So in theory, on line 18, we should see 65, and we do. Same with B. Well, B, there's no quotation marks. Therefore, it is a variable. Well, what is B set to? And we look up here and we see that B is equal to 78. Therefore, we see 78 being printed out. Okay, so, you know, good example here. And it definitely demonstrates how, you know, numerical formulas without quotation marks are evaluated, but anything with quotation marks are not, and we just dump that information to the screen. It also demonstrates how we use the cout or the console output operation with the less than sign to send output. All right, so you definitely want to be comfortable with, especially with C++, how to use the cout statements. Okay, for sure. So here they go a little bit more into detail, pretty much what I was going over up above there, explaining what this new line character does and how it pushes the cursor to the next line before it prints anything else out. Notice we can add multiple new line characters to the same string, and every time the computer hits a new line, it's going to send it down to the next line, new line, send it down to the next line. And that, you know, that's important, right? Because when we're displaying information to the user, we want that information to be readable. And a lot of times, in order to make that information readable, you want each piece of data on its own line. Okay, because half the battle is when the IPO paradigm, right? Input, process, output. When we input this data and we process it, we want to output it to the user in a useful form. And if we just throw everything on one line on the screen, that's not in a useful form. So definitely this endl and this new line character inside of a string is important, because it allows us to separate the data onto unique lines of output. Okay, and that's what this is trying to demonstrate. The other thing it's trying to show you down here is that if you have a big long string, this isn't too long, but let's just say you have a string here, you can actually print out this single line of output with two out statements. Excuse me, two C out statements, right? Where we can print the first sentence or see out the first sentence, and then we can see out the next sentence. Notice because there's no endl or \n here, both of these things are going to appear on the same line. Now there is an endl at the end here, but that comes here and it's going to push it to the next line. So we can always take a really long string and use multiple cout statements in order to output it to the screen. And then at the bottom here, they do talk about the commonly used escape sequences, right? We were talking about how \n is an escape sequence. Well, \n is what's called the new line, which moves the cursor right to the beginning of the next line, which is what we're talking about. But there are other escape sequences other than just new line, right? We've got \t, which is a tab, \b, which is a backspace. All of these are legitimate escape characters that you can use in the middle of your string to control the behavior of whatever is printed out. Okay. They demonstrate some of that here. Although, note to publisher, again, this is confusing because just way too many backslashes going on here. You should show a unique example for each one of these. This is just a little bit too confusing. All right. I will say this, that this is common. Anytime you want to show single or double quotation marks to the user as part of your output, you do want to use \quotation marks, because if you don't use \quotation marks, this escape character, it's going to think that this quote is the end of this quote and this is the end of the string. So if you actually want the computer to output quotation marks, you need to put a \ in front of it, which is why we see that this statement here is equal to this output here, where we actually have quotation marks around sunning. Okay, so sometimes we have to use the escape sequence, because if we don't, that particular, those double quotation marks has a completely different meaning without using those escape characters. Okay, so that is definitely why these escape characters are important, is because when we want to display those characters to the user, if those characters have special meaning to the compiler, we need to utilize an escape character so that they do not have a special meaning to the compiler. Okay. All right, and I think this is getting a little bit down into the weeds. Let's go to the next page here. All right, yeah, at the top of every program, as we have seen thus far, we have what's called these preprocessor directives, which are basically those lines at the top that have the #include, which basically tells the compiler to go out and grab the header file that is associated with a particular library. For instance, this IO stream is very common. It is what includes the CIN and the cout statements, right? The input and the output. And so you'll see a lot of programs include IO stream if they need to use CIN and cout, but there's a ton of other header files that we can use, and there's a ton of other libraries that we can use. And there's documentation for all of those libraries at this point online. If you know you need to use a particular method or function, you can just Google it. Well, what do I need to include for cout, right? What do I need to include for printf? And all that information is documented basically somewhere. And I'm sure there's official ANSI documentation for those libraries as well, but usually a quick Google search will let you know which one of these header files and libraries that you need to include for these different statements. And that just takes some time getting used to. Okay, it'll eventually become second nature. Oh, well, I want to use these methods or functions, therefore I'm going to include whatever those headers are that depend on it. But in the beginning, yeah, you may have the compiler complaining that it has absolutely no idea what cout is. And it takes a second to realize, oh, I forgot to include the preprocessor directive. I forgot to include the header file at the top. Okay, so these pound includes are very important, and we need to use the proper one for the proper methods that we want to use. And in particular, this chapter is talking about cin and cout, which is why we're using iostream. Okay. All right. Lo and behold, note the publisher. We're talking about cin and cout, but I guess they're trying to drill down. They're trying to present everything up front and get the wheels turning. And then they kind of drill down into the weeds. I'm a little bit more of a, I like to do things in the reverse, where we introduce all these things and then show how they all fit together. So that would be my recommendation to the publisher there. Okay, here's the other thing. So we need to use these pound include statements in order to grab the proper header files and the proper libraries so that the compilers knows what we're talking about and can compile our program. However, some of these libraries have very particular namespaces that they use. And a namespace is just a way to group like classes or like functions so that you don't have naming conflicts between the different libraries. Because what happened is, you know, a long time ago, let's talk about before there was C++, there was just C. A lot of different companies created a lot of different libraries. And eventually, if your program is big enough, your libraries are big enough, you start to use the same method names or function names as the other company. You start to use the same global variable names as the other library and the other company. And they were constantly getting name conflicts, right? Computers are stupid machines. We can't have more than one variable named the same thing. It's not going to know which one to use. So eventually they came up with this idea of a namespace where they said, well, everything in this namespace uses unique names. If you declare another namespace and give it another name, well, then you're free to use whatever variable names and function names that you want. Okay, so that's what the namespace is for, is it gives you a way to group like functions and like data together. And some of these libraries require a very particular namespace. iostream, which is what has our cin and cout statements, requires this std or standard namespace. You can get away with not using this, but you have to put this std. I don't even want to talk about it because there's always 100 different ways to do the same thing. As long as you're using cin and cout statements and you are using the iostream library, just go ahead and include this at the top of your file too. And you won't have to worry about doing any weird stuff. It'll just automatically know what C in and C out is. Okay, so this is kind of like a pairing. If you're going to use IOStream, make sure that you also use the namespace standard in order to make your life easy. Okay. And there's other libraries where they have unique namespaces and you have to pair whatever that library is with whatever that namespace is that it uses as well. All right, another preprocessor is called string, and it enables us to utilize a data type or a string data type that is able to hold data that is alphanumeric, right? We can't perform mathematical operations on it, but we can store alphanumeric data that can be presented to the user, or we can search or sort based on that different string data. So the string library is also a very important library that we need to include with any of our programs that utilize strings. And we haven't really seen, I don't believe, any real string data types being used up to this point, just numeric. So keep your eye out for this string preprocessor and string data type. All right, oh, here we are. After they've presented multiple examples, right, of how to write a C++ program, now here on page 81, we're describing what that format looks like. And I've kind of gone over this several times, where every program has a main method, and anything in between the curly brackets of that main method is what is executed first. Okay, so they've kind of waited until now to show you that, but if you've been listening to these webinars, you already know this. Okay. This seems redundant. I feel like we've already done this. These are variable declarations. IPO paradigm, these variables store the input to your algorithm, to your program, and they have to have a data type, and every unique variable needs a comma in between. Okay, and I feel like we've already talked about that, so that's a little redundant. Let's see here. What they're trying to point out here is that any line that has a semicolon is a single executable statement. So you can literally count the semicolons to figure out how many executable statements are inside of your code. And notice that not all statements have semicolons, right? For instance, int main that declares the main function does not have a semicolon. And in fact, the compiler will freak out, or actually, I don't know if it'll freak out. It will incorrectly define main as an empty method if you put a semicolon at the end. So a good rule of thumb is you put a semicolon at the end of the line if that line of code does not have curly brackets underneath of it. Because if it has curly brackets underneath of it, that's telling the compiler that, hey, all of this code here inside of these curly brackets is associated with main. You do not want to put a semicolon here because that'll cut the process short. All right, so semicolons are only needed when these statements do not have what's called a body. Okay, this is the main body. And the reason we know that is because we have these curly brackets around the main body. So we'll find out later on that not only do functions have bodies, there are other things like while statements or loops that have bodies. There are other things like if conditions, if and else conditions that have bodies. And with those statements at the beginning, you do not use a semicolon. And it takes some getting used to, because I can't tell you how many students that I've had that assume a semicolon goes behind everything. And the compiler is not going to complain. You can put a semicolon at the end here, and the compiler is just going to, I don't even think it'll give you a syntax error. It's not until you try to run it where all of a sudden you get some really weird behavior. All right. So good rule of thumb is if after the very next line you see a curly bracket or need to use a pair of curly brackets, do not use the semicolon at the line above that opening curly bracket, because that is a line of code that requires a body. Okay, so only use semicolons with statements that do not have bodies. All right, that's the rule of thumb. And a lot of higher level languages like Python have eliminated all of these goofy semicolons. They've eliminated all of these goofy curly brackets. The compilers are just smart enough to look at the code and not need all of these weird semicolons and curly brackets. All right, but old languages like C++ and Java, yeah, they do need these semicolons and curly brackets, and we need to know when to use them and when to not. Okay. All right. Here's another good example, 229, that shows us another good example of a C++ program, right? We include the IOStream preprocessor directive. Why? Because we've got cout and cin statements in our program. So we have to include that header file and that library. We say using namespace standard. Why? Because the IOStream library has a namespace called standard that we need to call out in order to find any of those methods. We declare a global variable called number that is a constant integer, which basically means that this value cannot be changed. So this variable called number is equal to the value 12 and can never be changed. We declare main, and remember that's where every program starts, is with main. And so the compiler, the computer is going to come in here, run main. It's going to declare an integer first num variable. It's going to declare an integer second num variable. And then it's going to say, okay, we'll go ahead and assign the value 18 to first num. So we have this value 18 inside of this first num variable. And again, I'm just executing the code from top to bottom. That's what computers do. There's no randomness to them. They're just executing a sequence of instructions. Okay. Now later on, when you learn about GUI programming, you're going to see that programs are event-based. They are not just sequential lists of instructions that they follow. They actually execute code based on certain events that happen. But we need to learn about, this sequential ordering before we talk about event-based code. All right, so we always start at the top and we work our way down. Here, cout, which means console output. This data, line 9 first number equals, and we go and we grab the value, right, inside of first num, which we said was 18. So we should see line 9 first num equal to 19 and then endl. So what we see here is line 9 first num equal to 18, and then the endl pushes it to the next line. Then we see line 10 and our integer. Aha, I think this is the first time we've seen cin. Cin stands for console input, and it basically says, okay, user, type in what you would like your input to be. And once the user hits enter with that input, it puts that input value, whatever the user typed in, into second num. Okay. So it's going to take whatever the user typed in, put it into this variable called second num, and then it's going to force the cursor to the next line here, right, with the cin endl. And that's what we see down here. So line 10, enter an integer, line 10, enter an integer. The reason they highlighted this 15 is because this is what the user typed in. is the value 15. And so that's going to take the value 15 and put it here into the second num variable. All right. And notice that, all right, we move on to the next line. Line 13, second num equals, and then second num. So we're going to output this because it's inside of a string, right? Whatever it's saying here in between the quotation marks. And then it says second num. We know this is a variable because it's not in between quotation marks. So we go grab whatever's inside of second num. Well, remember, second num is 15, right? So it should say line 13, second num is equal to 15. And that's what we see here. And then the next line of code says, well, first num is equal to first num, which is 18, plus number, which is 12, 18 plus 12, plus 2 times second num. Well, second num is 15, right? Because that's what the user typed in. So here, we have an equation with a lot of operations going on. So what the heck do we do here? Well, because of PEMDAS, multiplication needs to happen before addition. So we're going to take 2 times second num, which is what? 2 times 15, that's 30. We're going to take 30 plus number. Number is 12. 30 plus 12 is 42. Then we're going to take 42 plus first num. First num is 18. 18 plus 42 is 60. And that's why we see the value of first num is equal to 60. Okay, so I do like this example. It demonstrates how to use the cout and the cin in order to obtain user input, as well as a complex formula that has multiple operations, and we need to understand which operation is run first before the other operations. Okay. So again, we need to know how to read and interpret this behavior before we can write code, because that's what we do in elementary school. We learn to read before we write. Okay. All right. Understanding and fixing syntax errors. Oh, here comes the fun part. So, yeah, this reminds me of a lot of submissions I see for a lot of intro to C++ courses, and they are, I think, 90% there with this program. And if you're new to C++, you look at this and you go, meh, looks good, should run. However, computers are stupid machines. And if you are off by one character, nothing will run. And I already see 2 places that are off by 1 character. And if we try to run this program, you're going to see some output that looks like this. And the very first error that it complains about is on when you see output like this, when you see a number in the parentheses, that is telling you which line of code is giving the compiler problems. So in this case, it's saying, hey, look, line 9, I'm missing a semicolon before num. And if we look at 9, it has a semicolon. So this throws off a lot of students who are new to programming. They go, well, it's right there. What is it? This is crazy. Well, right, it's here. But what it's saying is before this line is missing a semicolon, if we look at the line above it on line 7, we will see, sure enough, there is no semicolon. So definitely a semicolon needs to be added here. What else does it complain about? Line 11, temp num undeclared identifier. We look at line 11, 2's fine. Well, num is declared up here, no problem. But look, temp num, we don't declare it or define it anywhere up here, right? Computers are stupid machines. You have to declare your variable, at least for the older languages. For the older languages like C++ and Java, you have to declare your variable before you can use it. And we never declare, it has no idea. Is temp num an integer? Is it a float? Is it a string? Like, what in the heck is it? And so that's what is complained about on line 11 there. Line 13, oh yeah, we're trying to use temp num again. And the compiler's saying, no idea. Temp num, never declared it up here. So I have no idea what you're talking about. And then what else? Line 15. Aha. Main function must return a value. And we're getting kind of down into the weeds here, but eventually we're going to learn that every function has a return value. In this case, it's an integer, and we're not returning an integer. Normally you return 0, and here we're not returning anything, and it's kind of freaking out about that. So notice how many little teeny tiny things are required just to get the C++ compiler happy here. Okay, we'd need to fix all of that in order to get it to run. And I think eventually you'd end up with a program like this, and it's happy. Why? Because we've declared, well, we already declared up here int num, right? Let me see. Yeah, well, we forgot the semicolon. So we declare int num and we add the semicolon. Int temp num was nowhere on the radar up above. So in order to fix these errors, we had to add an integer variable called temp num with the semicolon. And that fixed a lot of the errors below it. Once you declare that temp num, now all of a sudden temp num is defined here, it's defined here, and is happy here. And then that last error was about not returning anything. Now here we're returning a 0. So you can kind of see how, half the battle in learning how to program is learning the proper syntax of that language. All right. And in the beginning, it is a little strange and it does take time. And there is no shortcut. It's like learning French. It's like learning Spanish. It's like learning any human language out there. You need to study it, and you need to know what those verbs are, right? What those nouns are, what those adjectives are, when to put the semicolon, right? When to put the data type, when to declare the variable. And it just comes with practice, as well as hopefully a good explanation of the example code, which is what I'm trying to provide here, right? Teaching you how to read code and interpret its behavior, not just, we'll type this in and see what it does, because I think that's what a lot of these textbooks are lacking, or they present information in a very strange order, right? So with that said, I think that's all the time I have for today. And yeah, we're going to have to stop it here. Again, if you find these webinars useful, please, like the video, leave a comment, let me know. That's what keeps me going. I'm trying to bridge the gap from all this technical information that's in the textbook. And look, these textbooks are amazing resources. Okay, at the end of the day, if you're going to become a software engineer, you need an entire bookshelf full of textbooks, because here's the thing, every textbook has probably 10,000 Google searches in it. You could probably get by with Google alone, but you're going to be doing a lot of Google searches. These textbooks have already done a lot of this research for you. They've already got a lot of good examples baked in. So please do not underestimate the value of a textbook. And that's what I'm trying to point out to you here. So with that said, have a great rest of your day and study hard. And let's hope to talk to you again soon.